Okay, next part we'll go to linear regression. Linear regression essentially is the thing that we do to not just say, oh, these two are related. Okay, we will draw a best fit straight line. You want to learn about best fit straight line, right? From O level until now, don't tell me you don't know best fit straight line. Don't know? No lah, best fit straight line, you know ah. How do you draw best fit straight line? Can I ask? How? How to draw best fit straight line? In your science lab, you don't do best fit straight line. Or am I from Don't scare me lah. Different era, man. Different generation, eh? Of course not. Oh, surely you draw best fit straight line, right? Now, linear regression is about drawing the best fit straight line. But we are going to be a bit more mathematical and systematic here rather than going by feel. We are going to draw a perfect best fit straight line. You know what I'm trying to say? Okay? Now, can I have your attention, please? Chemistry, chemistry. Okay? I don't do chemistry, but never mind. I can still say a bit. Okay? If X... Hello? Are you okay? Are you okay? If X is the time, X is the time, and Y is the mass of the chemical produced, whatever, surely in this case, there is what we call an independent variable and what we call a dependent variable. The independent variable here is time because you can control the time. What is the result is your mass of your chemical produced. So we must identify that first. That's why when you sketch your best fit straight line or your science experiment curves, you must choose the right horizontal axis and y-axis, right? And vertical axis, right? Yeah? So when we will usually regress y on x, and we draw a best fit straight line. Like I said, in your science experiments, when you sketch, you will just say, I want to minimize the distance, so I just draw a best fit, right? Now we are going to learn really how exactly to sketch it such that it is indeed a true best fit. Now the method we're going to use in this case is what we call a least square. We want to minimize the distance between the data points and the best fit straight line. Okay, I'm going to do it, I'm going to explain it using the sketch here. Okay, now you have on your graph, or you have on your notes, what do you have? All the, where is it? Here, okay. You have all the plots, right? You have all the points, right? And then you draw a best fit straight line, right? You are going to draw, the line is determined. If you have this point here, this is a data point. This is a line. We call this P1, we call this Q1. Just label first, label first. You have another point. P2, Q2. Because P is one point, a data point, P2 is another data point, right? In this case, P3 exactly lie on the line P3, Q3. Now, the line you draw will be such that you take distance PQ squared, distance PQ squared, distance PQ squared. That sum is a minimum. Do you know what I'm trying to say? You will take it, you will draw the line such that the PQ squared, PQ squared, PQ squared will be a minimum. You should be able to find such a line. Do you know what I'm trying to say? Don't know. Okay, one more time. Okay, I will use a. Okay, Yours, finish this up first. Okay, then I'll explain. Yeah. How you know later? Oh, but the idea is like that. Okay, science experiment. Science experiment. Okay, you have 1 point. You have 2 points. For simplicity, 4 points. Correct? I have P1, P2, P3, P4. Now then you tell me AI roughly lah, anyhow lah, best fit lah. Draw a line. Now the line that you draw, the red line you draw, is such that you should minimize this distance, minimize this distance, minimize this distance, and minimize this distance. If you can draw another line where those distance is smaller, then that is that line. Now, how later we'll decide. Okay? But the idea is that. Do you know what I'm trying to say? Okay? The how later we will find out. I am not about to tell you how to, or rather we are not about to go through some rigorous math to do this, but there is a way to do it. I will just tell you the formula. Okay, there is a formula. Okay? Then you can throw it to your chemistry teacher. Hey, I know how to draw best fit straight line already. You just, wow, busy crunching numbers during SPA. No need, sorry, I don't mean that. I don't want to. You know what I'm saying now? Yes? Okay. How? Okay, now the how, right, Samuel? Now the how. How do we find? Of course, a best fit straight line should have the form y equals to, it's here. Y equals to ax plus b. Correct? Y equals to ax plus b. Straight line, what? Of course. If I tell you that it's a magic formula to find what is a, what is b, done, no, you can sketch already, right? So I'm about to give you the magic formula. Okay, I'm about to give you the magic formula. The b especially is super important. Found in formula list. Found in formula list. But before I give you this magic formula, we must first know that whatever line you draw, the perfect straight line you draw, it must pass through x bar, y bar. What is x bar, y bar? It's the average of x, average of y lah. Which means this, you know. Which means this. Wait, where is it? Oh, okay. Which means this. If you take, this is x1, x2, x3, x4. And you realize the x bar is somewhere here. This is x bar. Take average of 4x. Then you have y1, y2, y3, y4. Then in the end, this is your y bar. This regression line must pass through x bar, y bar. You know what I'm trying to say? Must pass through. It can be shown now. I'm not about to show you lah. You can research. Go and Google and Wiki, whatever. Okay? It can be shown. Okay? Can? So this is an important point. It passes through x bar, y bar. Alright? So therefore, if it passes through x bar, y bar, this equation can be found. And therefore, you can actually find A if I tell you what is B. Correct? Now B is this messy looking thing. Again, given in the formula list. So easy, right? So just substitute. No big deal. Okay? Can? Okay, I'm about to give you a break. I'm aware, about almost an hour. Sorry. Okay, I'll just finish this and I'll give you a break. B is known as the coefficient of co-regression. Sorry. B is just the slope of the regression line. It is not R. Don't confuse B with R. R can lie between -1 and 1. B is just a slope. Alright? Regression line y on x gives an average value of y for a given x. What do I mean? That means after you sketch the regression line and somehow if you want to know what is 0.7, if x is 0.7, what is your y? Use regression line to find out. Sub into your regression line, you know what is y. It's to estimate. You know what I'm saying? Alright? Let's say you eat X amount of dark chocolate, and then you want to know how long you live, kind of thing lah, huh? Very stupid, right? Eat us. Okay, anyway. Okay? Maybe I should change the example next year. So stupid. Okay, anyway. The least square regression line is used. Okay, now, can I have attention? Now we are going to talk about y on x. Later on, we're going to talk about x on y. We must know the difference. We use y on x if 1, x is the independent variable. That means nothing can change x. For example, your time of experiment, you control the time. The mass of the chemical is the result. So cannot control. The x must be the time must be independent. So if that is the case, just take y on x. But if neither variable is controlled, if neither, let's say for example, H2 math score and H2 econ score, which one is your horizontal, which is your x, which is your y, or other which is your independent, which is your independent, actually no one, right? You will choose the one, alright, if you want to, okay, let me put it this way. If you neither variable is controlled and you want to estimate y for a given x, that means if you want to estimate econ score for a given math score, then your x, then you use econ score on math. Do you know what I'm trying to say? Okay? Yes? So, after we finish this table, we will have a break, okay? Time and mass. Which is the independent? Time, right? Time. Amount of fertilizer and the amount of growth. Which is the independent? Fertilizer, right? Correct? What about the weight at the end of a spring? Most of you do physics, no? Okay, some do physics. Anyway, this is O-level physics. Weight at the end of the spring and the length of the spring, your extension, your E. Which is the dependent, which is the independent? Of course, the weight is the independent. Now, if we talk about mid-year score and end-of-year score, mid-year score and end-of-the-year score, if I pick one student, I check with you, hey, what's your mid-year, what's end-of-year? What is your mid-year, what is end-of-year? Then actually there is no dependent or independent. There is no dependent or independent. They are not anyone is independent, so there is none. What about the hand span? That means span of your hand and the height. Again, none. Not one related to another. Or no one is the ultimate independent variable. Really none. Okay, sorry. We had a long... Okay, now we'll break. We have a break, and we will come back at 12:15. 15, can 15? 7 minutes? Cannot lah. Okay, 16. Bargain. Let's see, 16. Okay, 16, come. Let's go. 16, 12, 16.